This is awesome, guys. Keeps me from staying up here till midnight. Alright. I went up 2, and then I ran how many? 1, 2, 3, 4, 5 to the right. Right 5. That's vector A. Okay, B, from the tail to the head, I went what? Up or down? Down 2, and then right how many? C, I went up or down? Up 3, right 2. Okay. I want to add A plus C. So vector A, I start somewhere. I'm going to start, just say, right here. Okay, vector A, I'm going to go up 2, right 5. 1, 2, over 1, 2, 3, 4, 5. And draw a vector. This is vector A. Okay, I'm going to add vector C. I'm going to start at the head of the first one. Okay, I'm going to add plus C, so I'm going to go up 1, 2, 3, right 1, 2. Okay, this is vector C. My answer is the resultant from the head or tail of the first one. Is this the head or tail?
That's the tail.
Tail to the head of the second one. And that represents my solution right there. Vector A plus vector C. Are there any questions on that? Alright, let's look at number 2. Vector B minus vector 2 times C. Vector B has no negative in front of it, so I'm going to do just like it is up here. I'm going to start somewhere right here. I'm going to go down 2 and right 3. That is vector B. Now, since this is a minus and a 2, I'm going to go to C. Now I'm going to multiply both these numbers by what? By 2 and go opposite direction, okay? So instead of going up 3, I'm going down how many? 6. Do you understand that? Okay, so 1, 2, 3, 4, 5, 6. Instead of going right 2, I'm going left how many? 4. 1, 2, 3, 4. And when I label this, I got to put a negative 2C to let people know that was a negative 2. Okay? Oh, I'm sorry. Now I'm going to connect from the tail of the first one to the head of the second one and label that vector B minus 2C. Are we good on those? Do I need to do the 4 times A? You know how to handle that one? Just multiply. Do I need to do that one?
Can we do it, please?
Okay, sure. Alright. Now here, will you have this big diagram for this one? No, you don't have one single vector. You're just multiplying by 4. Okay. And when you multiply a vector by just a number like that, it's called scalar multiplication. Scalar multiplication. So here, I'm going to start here. I'm going to multiply this. So it's by 4. So instead of going up 2, I'm going up 8. And right 20. I can't draw that. We're not going to draw that. But you know that's what, you saw that coming, didn't you? Conley, you're evil sometimes, aren't you? Mm-hmm. But you would go up 8 and right 20. You okay, Zach? Okay, you have a picture like this tomorrow. Let's look at this. Look at this I came up with. Beautiful. Okay, true or false? Vector A plus vector B equals vector F. Is it drawn correctly? What? No, it's not. Okay, no, that's false. Because it should, the arrow should be going that way, shouldn't it? So we could rewrite that as vector A plus vector B equals what? Negative F. Because it's drawn the opposite direction what it should be drawn. Does everybody understand that? Because it should be going from here to here. But it's not, so I'll redrew it like that. Alright. Vector C plus vector E equals vector D. Is that correct? Yes, that's true. Okay. Vector A plus vector B plus vector C plus vector D equals 0. Is that true? Yes, because you started and ended up where that started at 0.
Was there 2 vector D's?
I don't know. This is not perfect. Alright. Okay. Let's just go through. You already done this page, but I just want to make sure you understand what it's asking of you if you have these directions on your test tomorrow. Good morning. It says write each vector in component form. What is the formula for component form? 2D. X sub 2 minus
X sub 1,
comma.
Y sub 2, Y sub 1.
So you know how to handle that. How do you find the magnitude of the 2D vector? Greg? Oh. I hope I don't got you on this simple question.
A squared root of A squared plus B squared.
That's how you find the magnitude. Does everybody understand? Don't come up here tomorrow and ask me at my table, I don't know what it's asking. I'm going to say, I don't know either. Okay. You know how to find the operations with 2D vectors, don't you? If it is in component form, your answer is going to be in component. If they give it to you in linear combination, it will be in linear combination form. Do you know how to find the dot product and determine if it's orthogonal? You multiply this times this component plus that component times that component. Same thing for linear. You would say this times this plus 4 times negative 6. Okay, when they give you the magnitude and they give you the angle and they want you to write it in this form, AI plus BJ, or component form AB, how do you find A? A equals what? Magnitude times cosine of angle. What is B equal to? Magnitude times. Very good. And we just went over one like this. Okay. What is the component form of a 3D vector?
X sub 2 minus
X sub 1, comma,
Y sub 2
minus
Y sub 1,
comma, Z sub 2 minus Z sub 1 end. Okay, what's the magnitude? Square root of what? A squared plus.
B squared plus C squared.
Very good. Do we know how to operate with these vectors?
Oh, yeah.
We know how to find the dot product of this. You would say 3 times what? Negative 8, and then plus negative 9 times 2, and then 6 times, and add them together. Are we good on that? Okay. Let me do that. I just want to review this quickly.
Hey, Mr. Rush.
Don't get too bored, BT. Yes.
You know, it'd be sweet
What?
if we had class and recorded on one day.
We will. When it heats up.
That'd be sweet.
It's a little chilly. Okay, let's just make sure. Okay, let's say I'll give you a graph. I'm going to give you one like this tomorrow. And let's say we want to graph. Give me a point.
3, 4.
Are these called ordered pairs or ordered triples? Okay. What is it, Conley?
3, 4, 5.
Something a little bit more challenging.
3, 4, 7. 3, 4, 10.
Could we not have thrown a negative number in there? Okay. 3, 4, 7. Start at the origin. Going right on my x-axis. 1, 2, 3. Go up on my y. 1, 2, 3, 4. And then up 7 on my z-axis. 1, 2, 3, 4, 5, 6, 7. That would be my point there. That's awesome, isn't it?
Do a negative.
You give me one, Max. Which one? Give me an order triple.
Negative 5, 10, 11.
Of course, I'm not got 10 and 11.
Negative 5.
Yeah, we're going to do it. We're going to do it. Watch this. We're going to do it. Negative 5. Here we go. 1, 2, 3, 4, 5, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we're going up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to call that max right there. I'm going to make your test special on this. I'm going to give you one like negative 50, 32 tomorrow and say take as many pieces of paper you need to. Yours will be special, uniquely made. Are there any questions on that?
Is that all we're going to have to do with the 3D?
Yes. Mm-hmm. Yes. All right, now, I want you to turn to page 13 quickly in your notebook. I'm going to rearrange some things. This is just still part of review. We're about to go over your homework, okay? I promise. I'm just trying to get all the review out before we get started. We're not going to work these. I just want to know if you saw something like this, you know what to do. Like on 5 and 6, when it says position vector, it means component form, but I think you won't have that depiction tomorrow. But what does this symbol mean? If I had this right here, what does that mean, class?
Magnitude.
Find the magnitude. And how would you find the magnitude of something? You don't have to do this. I just want you to talk about it. How would you find the magnitude? What's your A value here?
5.
And your B is negative 12. So square root of 5 squared plus negative 12 squared. Is everybody good with that? Okay. Here, these vectors are in linear combination. So if you're adding, subtracting, multiplying, dividing, your answer is going to be in linear what? Linear form. Now this one right here, would you do what's inside or do magnitude first? Inside, and then you would do the magnitude. So your magnitude, you would have one single number as an answer. Does that make sense?
Yes.
Okay. Here, would you do magnitude or subtract first? Magnitude. Very good.
Would it still come out the same if you did magnitude of B minus the magnitude of W?
Okay. It's like order of operations. Now here, it says find V dot W. That means dot product. Does everybody understand? That means dot product. Okay, how will we do dot product here? 2 times 3 is 6, plus negative 3 times 2 is negative 6. What's 6 and negative 6 give you? 0. So are these two vectors orthogonal?
Yes.
What does orthogonal mean? They are perpendicular. Are we good on our review? Okay, let's go over homework now. Let's look at number 46. Let's go over the bottom first. The bottom's the easiest, isn't it? Check your work on 51 and 52. 51, you can leave it in that form, y equals 5 plus x minus 2 over negative 3. First, on the x equation, you solve, get t by itself, and then plug that in the second one. If you found a common denominator of negative 3 and went from there, you're a model student. I'm proud of you. But if you left it like that, I will accept that. Now on this right here, should you cross out the 2 and 4? Should you? Yes. Because on that one right there, I get t by itself. I get x plus 3 over 2. I substitute that in there. There's no plus or minus here, so I cannot cancel that out. And I think you should be able to continue on doing that. Y equals 3 minus 2x. And number 53. I want you to do 54 and 55 right now. Yes, sir. You can take a 2 out. Because it's 4 and 2. Take a 2 out and there's a negative 2 there. Good, Jordan?
I need to go to the eye doctor.
Oh, I'm sorry.
You're good.
Can everybody see from their desk? I'll put your notes right there. BT. Yeah. Well, if you need to get up and walk over there and copy your learning card down, you can anytime. No. See, there's a reason you're on one side of the room and Zach Moon's on the other side. Everything's strategically placed for a reason.
Except for I forgot to take Jordan's eyes on the curriculum.
As soon as I don't listen to him.
I'm good. I tune him out a lot. See, first semester he used to make me really mad. And then I adopted his carefree attitude. Do it if you want to, do it if not. That's what reflects on the report card. I used to get ulcers in my mouth and my stomach, I think, and they were probably called Zach. But you know what? If he's carefree, I'm carefree. You used to I thought it reflected my teaching, and I said, no, you know what? It reflected his non-study habits. But I love him like a son, so I just don't let him. I love him anymore. let's look at 54 and 55. Number 54, we want to get t by itself. So that's going to become x plus 1 equals t. Now I'm going to plug that in. Y equals x plus 1 squared minus 3. You could leave it like that. Alright, number 55. I'm going to move that, that's going to be x minus 4 equals negative t squared. I'm going to divide that by negative 1. That gives me negative x plus 4. Watch what I did there. I want to make sure you understand. There's a negative 1 in front of that t squared. So I moved that 4. It became a negative 4 divided by negative 1. Now I'm going to take the square root of both sides. Now I'm going to take this and plug it in for t on the other one. It's the square root of negative x plus 4. Sorry.
Do you have to do that for the x?
What now? What did you do on?
The y equals t is just, I just substituted that into the t.
You could do that. I just always start with the x equation.
Do you not get the same?
Yeah, you did. If you take y equals t and you plug y in here, and then you get y by itself, you will come up with the same thing that we just got. Are there any questions on how to eliminate the parameter? Are we good on that? That's on your test tomorrow. And why do we study parametric equations again in this unit? Because these equations have magnitude and what? Direction. They have direction. And what? And parametric equations takes into account a third variable. What's that third variable?
T.
T, which stands for time. What's going on with the x coordinate at this certain time? What's going on with the y coordinate? So it's that third variable, time. Okay. So we're going to look at 46, 47, 49 and call it a day. Well, you have some homework you can work on. I'm going to call it a day for 46, 47, 49. All right, let's look at 46. We have x equals t plus 2. Y equals t squared, negative 2 less than or equal to 2 less than or equal to 2. What? I know, thank you. You're going to be my police that monitor that, okay? Alright, now, what notation is this called? Is this called interval or set?
Interval.
Interval is when we have the parentheses and bracket. Isn't that correct, Mr. Brown? So, set. This is set notation. We don't use this much, but that is known as set notation, okay? Interval notation, we use parentheses and brackets. You're given intervals. Do you understand? Do we know the difference? Okay. Now, what do we use more of? Do we use more of this or interval notation? Interval notation. That's what you use in college. I just want you to know the name of that. Okay, so, let's make a chart with 3 variables. Okay, my interval is from negative 2 to 2. So there's my thing. Now I'm going to plug these values in for x. Negative 2 plus 2 is 0. Negative 1 plus 2 is what? Negative 1 plus 2 is what? 1. 0 plus 2 is? 1 plus 2 is? 2 plus 2 is? Thank you. Now I want to plug them into y. Negative 2 squared is? Negative 1 squared is? 0 squared? 1 squared? 2 squared? Now I'm going to come over here and draw. Okay, so I'm going to graph 0, 4, 1, 2, 3, 4, 1, 1, 2, 0, 2, 0, 3, 1, and 4, 4. Okay. I'm going to graph in the order I went. Come back and put arrows on here. Do I need to put an arrow at the end of these 2 endpoints? No, because I'm just focused on that interval. Does that make sense? Okay. Remember, you're absent yesterday. I posted a video to Google Classroom. Just know that is the norm now. If I'm here and I'm teaching, I'm gonna when I finish this, I'm gonna upload it to Google, and you need to watch it. All right. Number 47. We have x equals negative sine t, y equals negative cosine t, and an interval. When they give you an interval like this, just use your major points. Use your major points. So x equals negative sine t, y equals negative cosine t. My coffee's in that cold back here. Hold on.
See if we have microwaves in the teacher rooms. Those are negative comment, Daniel.
I was about, and you just got all of my business. I was about to correct him, Max. Thank you. I was about to correct him, Max. Thank you, though, for taking my role on and finding it in your place to do that. No, that was kind of a negative one. So I'm going to have to separate you and Max because I can't have y'all teaming up back there. All right. Now, major points. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now, I'm going to plug this in the x equation. Get your head up, Big T. Sine of 0. Look at me, T. Sine of 0 is what, class? Automatic. What is it? 0. Sine of pi over 2. 1, but since there's a negative, it's going to be negative 1. Sine of pi? 0. Very good. Sine of 3 pi over 2. Negative 1. That negative 1 make a positive 1. And sine of 2 pi. Now let's go over cosine. Cosine of 0 is 1. There's a negative, so it's negative 1. Cosine of pi over 2. Cosine of pi? Negative 1. A negative 1 gives you a positive 1. Cosine of 3 pi over 2. Okay, and cosine of 2 pi? Negative, it's going to be negative 1. Now let's graph this. I'm going to come around and check your homework in just a second for a homework grade. 0, negative 1, negative 1, 0, 0, 1, and 1, 0. And there's your sweet little circle right there. It looks like a wagon wheel. I almost played that song for y'all today.
Why would the arrows not go together?
Because you graph it in the order like 0, negative 1, it's going toward negative 1, 0. You see that in the order of which you graph it. 0, negative 1, then I graph this. Does that make sense? Alright, let's look at number... Why do you think I omitted number 48? I want somebody to impress me. Look at the interval. Why did I omit 48? What tier? Why do you think I omitted that one? Y'all are some of the smartest kids in school. Why did I omit that? Look at the range and look at the problem. What would occur?
Doesn't exist.
Why? Which number's in the interval?
2.
Okay, I'm input number from negative 2 to 2. And what number's in that set? 0. Isn't 0 in that set? Can you have 0 in the denominator? So that problem wouldn't have worked. Does that make sense? Think about it. Y'all are intelligent. Don't give up. Productive struggle. Productive struggle. You're going to have to be problem solvers one day. Okay, 49. X equals 3 minus t squared. Y equals 2t. And we want to know what's going on from negative 2 seconds to 4 seconds. And why? This negative 2 is talking about 2 seconds before the projectile was released, okay, or whatever was released going on at the moment. All right. All right. So negative 2, negative 1, 0, 1, 2, 3, 4. Ooh, a lot of points here. All right. Now you're smart. You can do this here. Negative 2. Negative 2 squared is what?
4.
But there's a negative, so that's going to be 3 minus 4, isn't it?
Yep.
So negative 1. Negative 1 squared is what?
1.
3 minus 1 is going to be?
2.
0 squared is 0. What's going to give me? I like that, Max. Keep going.
3.
3. Plug 1 in. 1 squared is? There's a negative sign there in front, so 3 minus 1 is? 2 squared is? 3 minus 4 is? 3 squared is? 3 minus 9 is? 4 squared is? 3 minus 16 is? Ooh, good job, guys. Smart right there. 2 times negative 2 is? Let's go down the line. What's the next one? All right. You gave up?
I just stopped at 6.
Oh.
I just didn't know the last one.
That's fine. You know, life's about choices. So when you're in the real world one day, being an engineer, being a math teacher, and you run into a difficult situation, you're just going to give up on that child.
Well, it ran
You're going to give up on that child.
No.
No. Because you're a good teacher. I always believed in you, Hannah. Remember that? There's some days that I want to... I can't say that. -1, -4. 2, -2. 3, 0.
Mr. Hester, we can't see.
Okay, figure out what's going on. I'll just go. 2, 2. -1, 4, 2, 2.
See, watch what happens.
But I didn't give up. That's a pretty graph right there. Pretty amazing. That's beautiful. It's a beautiful language, y'all. Always remember that. It's a universal language. Every number looks the same in societies. Look at that. Look at that. That's right. Beautiful. Are there any questions on homework? Keep it out because I'm coming around and check it. Grace. When I call Grace here, show me one. When I call a person's name, put their name on it, that means I'm looking at homework. Call me. You have to have it calmly ground. TJ absent, Noah absent, and Catherine's absent. Okay, your homework is more practice. Turn this in, page 13, numbers 15 through 19. Let me see what the directions say. Okay, let's look at this. It's page 13. You're going to do numbers 15, 16, 17, 18, and 19. It says graph the curve using a T-table. That's what we just did. On problems 15 and 17, after you graph it, they want you to eliminate the perimeter. Only on 15, 16, and 17, okay? You don't have to do that on 18 and 19. Just read your directions, okay? Page 13, numbers 15 through 19. It doesn't give you a range. Okay, on number, which one is it? 16. You can omit 16. Just do 15, 17, 18, 19 since it didn't give you a range. Okay, thank you.
Hey, Mr. Hester.
Yes.
So, if I'm trying to leave my house, because I left at 7:30 and got here at 8:10, and I live like on Thompson Road. So what do you think I should do? You know, get here at 8:15 on the dot?
No.
Or what should I do?
I don't know. Think about it. Brainstorm.
So I gotta